So we, as with all projects, start with the learning objectives, and we break those down into what are the key skills and knowledge gaps that we need to cover. And then we map those, in this case it's VR, to what are the visuals, what are the immersive visuals, what's the interaction flow. So there's a whole design system between the learning experience designers, the UX designers, the developers, the Unity developers, or Unreal if we're using it, and all the kind of templates and design documentation that they use to facilitate cohesion and synergy between all their respective expertise.
Yeah, so just to recap for those of you watching this that didn't watch the webinar, a web-based VR experience or a WebXR experience is one that's accessible on both desktop computer and VR headsets. So we're able to create immersive experiences that have wider accessibility and more options in terms of how people consume them. And so when building these experiences, our goal is really to create a single unified experience that adapts seamlessly to different devices. And so when it comes to the controllers, when accessing the experience through a VR headset, learners just use the headset's controllers to interact with objects and elements within the virtual environment. And they can naturally turn their heads to look around and explore the 360-degree space. So it's a more intuitive experience and a truly immersive experience. When accessing the same project on a desktop computer, on the other hand, learners can use their mouse or trackpad to navigate the 360-degree environment that way. And they can click and drag around their mouse to look around, zoom in, zoom out, explore the virtual space. So the keyboard inputs are used instead of the controllers in this case as a way to interact with the simulation.
So we're actually doing a lot of R&D to productize more and more different AI L&D products and different features and functionalities. So evaluation is one, evaluating performance, providing real-time feedback and coaching in the moment to encourage the learner to reflect and have those metacognitive skills. So we're working on an AI evaluator, an AI coach. Also assimilation, so AI that connects learners that have similar maybe problems or insights or ideas or challenges in the moment, assimilating knowledge of the organization maybe to gain more strategic insight. Curation as well, so curating personalized pathways on demand, usually leveraging the functionalities of the LMS as well, and simulating a workflow. So lots of different AI features and functionalities and products that could be integrated depending on the objectives, the business and learning objectives. Overall, I'd say we're integrating all those to provide a more personalized and adaptive experience for the learner. Another example is AI-driven branching scenarios. So that's when the AI might adapt in the moment, provide different challenges and different feedback depending on how the learner's doing in the simulation.
So our emerging tech team has worked really hard on solving this particular challenge. Our goal is to make VR more practical and scalable for organizations and easier for learners to access. A big part of this work has been to develop an LMS integration tool which allows us to seamlessly embed web-based VR experiences directly with an organization's LMS. So this means that learners can access immersive simulations and scenarios just as easily as they would an e-learning module or a video, for example. So when a learner goes to an LMS, they'll click on a link just as they would in e-learning, and they'll be able to launch a WebXR or VR experience from that LMS. They'll then be presented with a pop-up box giving them the choice to continue on their desktop computer or transition over to a VR headset if they have one. So this provides flexibility and really caters to different learning styles and preferences, and allows for that seamless transition between devices. And then all the data that's collected during the experience, such as progress, performance, any assessment scores, that's all automatically fed back as well, allowing you to track learner progress and measure the effectiveness of the immersive learning program.
We talked about 3 different strategies that ensure that skill transfer happens from the VR experience into the on-the-job experience. One was embodied practice. So that's the use of our actual physical bodies in VR to strengthen muscle memory and activate cognitive processing, getting our vestibular systems involved, our sensory motor systems involved. That can actually help our decision-making skills and make that real-world application more intuitive. Situational awareness as well. VR is engaging our 360-degree senses and awareness of the environment. So we can incorporate spatial audio and haptic feedback and that peripheral vision to really mimic the real-world environment. And that can help transfer those skills into dynamic real-world situations. And then 3D visualization, we also talked about interacting with complex 3D objects. Maybe it's anatomical models. We talked about a heart simulation that we created, machinery or different tools, allowing learners to manipulate and explore those systems in VR that helps their spatial understanding and their functional understanding that they can apply in the real world afterwards. So those strategies will improve the skill transfer, but you also have to think about measurement in the real world. So partnering with maybe it's managers or other colleagues or stakeholders to develop observational protocols to measure those behaviors and skills in the real world afterwards. Maybe it's post-training assessments or employee surveys to help track that retention and the behavior change and the job performance to make sure that the immersive learning leads to those actual improvements on the job.
So knowing upfront that your industry has regular compliance and process updates, that definitely helps us to create and design a more flexible and adaptable VR training solution. So to ensure your training stays current and relevant, we take a proactive approach to updates and revisions. For simple text and content changes, we can usually turn those around within a few days. More complex updates like modifying the 3D environment or replacing assets, those might take a little longer, maybe a few weeks, depending on the complexity. So during an initial phase of the project, we'd really work closely with you to identify the areas where updates are most likely to occur, allowing us to build in that flexibility. And then, of course, we also offer post-launch maintenance packages to provide ongoing support and ensure that your VR training stays up to date with latest compliance requirements and any industry best practices. So whether this is including regular reviews, content updates, technical support as needed, of course, we're committed to creating VR solutions that are not only engaging and effective, but also sustainable and adaptable to evolving needs.
Well, I'm somebody who loves roller coasters, but I take comfort in seeing those black rubber bars right there in front of me when I'm on the ride. So you can kind of think about what is the equivalent of those roller coaster bars in the VR scenario. So reference points, how could you anchor the learner's point of view? In the case of a driving simulation, that could definitely be the dashboard, having the dashboard there, or having the horizon in the distance. Those will definitely help. So just stable reference points that they can see. And then definitely limiting acceleration and de-acceleration intensity. So gradual acceleration, maybe having different levels of acceleration to help them get used to it. And then incremental exposure training is another one too. So not expecting, especially a learner that's maybe never done VR before, expecting them to go in for a half hour, maybe thinking about intentionally, mindfully designing your program for those increments, maybe exposing them for 5 or 10 minutes at first, and then more once they've become more used to it, and you can kind of reduce their discomfort over time.
So the choice really depends on the learning objectives and the desired level of interactivity. So video or photo-based 360-degree experiences are really powerful at creating realism and that emotional connection because you're using real people and places. So this is perfect when you need that grounded human context, or if the goal is maybe to capture real-world environments and scenarios, maybe a workplace tour, for example. On the other hand, digital or computer-generated environments offer incredible flexibility and interactivity. So here, learners can manipulate objects, they can experience scenarios that might be impossible to film in the real world. For example, think of a machine safety experience where learners could open valves, turn knobs, and really see the consequences of their mistakes as it relates to personal injury, for example, or just damage to equipment. So that level of detailed interaction wouldn't really be feasible with photos or videos. A computer-generated approach also allows for greater control over the environment and the assets, which, going back to the previous question, makes it easier to update and maintain the experience over time without needing to refilm an experience, for example. So all of that to say is that we always start by carefully considering the learning objectives and then determining which approach will best support those objectives and create the most engaging and effective learning experience going forward. So the development timeline for a VR experience can vary quite a bit depending on the complexity of the project. A straightforward VR scenario with basic interactions might take around 12 weeks to develop, while a more complex experience with more intricate environments and advanced features could take up to 20 weeks or more. Factors that might influence the timeline include the complexity of the VR environment, the number of interactions, the number of scenarios, the level of customization, and maybe even the need for integration with other systems. So for a project like the Hilton Business Immersion, which involved several environments and scenarios, multiple interactions, the development timeline for that project was approximately 16 weeks. Okay, so again, the development timeline can vary significantly based on the complexity. So given the highly specialized nature and the high stakes context of certifying physicians in the use of a new medical device, as described here in the question, we're definitely looking at a more involved project, in this case with a need for, it sounds like, meticulous accuracy, complex interactions, and potentially integration with medical equipment or software. So I would estimate a timeline of 20 to 24 weeks, maybe more. Of course, the exact timeline would depend on the specific requirements of the project, and so we would want to work closely with you to define the scope and develop a detailed project plan.
So we have pretty extensive experience in that space using VR to simulate difficult conversations and develop soft skills and leadership skills using things like AI and NLP, natural language processing technologies, or voice analysis and recognition technologies to analyze their performance in the conversation. Yeah, so we've developed a few VR trainings for technical maintenance and installation procedures that we're not allowed to show, which is frustrating because a picture is worth 1,000 words. But definitely any kind of think of complex physical and procedural tasks using machinery or hardware, definitely well supported by VR, where the learner's actually getting to use their bodies and virtual tools. So you could imagine electricians cutting wires, or maybe just wiring circuits correctly without any risk involved when you're in the VR environment. HVAC technicians, factory workers assembling machinery and getting real-time feedback on how they're doing. Also, is it safe? Or do they have the correct posture? Are they following safety protocols? So hands-on VR simulations really allow them to practice repeatedly, right, over and over again, safely. Maybe even using haptic gloves. That's another thing we haven't mentioned, but not just if there's budget and feasibility to invest in haptic gloves for a complex physical procedure, or maybe a specific tool where the hand controllers just aren't going to support the agency that the learner needs to have, the hand agency they need to have. Haptic gloves would be great. And then they can just, like we said, do all those things in risk-free environment. And you could even simulate really unique or anomalous situations in VR, so they feel really prepared for anything when they go into the field.
So yes, we've found that VR can be incredibly effective for compliance training, breathing new life into what can sometimes be dry or unengaging material, as we all know from anyone who's taken a compliance course in the past. So it's really one thing to read about safety procedures, for example, but it's a whole other level of learning to actually experience them in a highly realistic or immersive environment. So we create these VR simulations that replicate real-world practices and real-world workplaces, allowing learners to really put into practice maybe identifying hazards, making critical decisions, experiencing the consequences of their actions in a safe environment. So this goes beyond passive learning, really encouraging that active participation and decision-making through interactive scenarios. For example, we've developed VR safety training experiences for manufacturing environments where learners identify risks, mitigate hazards, practice standard operating procedures. And then moving beyond safety training, we've also leveraged the power of AI to create immersive experiences for compliance training that focuses more on soft skills. So, for example, we can develop conversation simulations where employees practice navigating sensitive compliance-related conversations, maybe those involving anti-harassment or anti-bribery policies. In these simulations, learners can engage in realistic dialogue with AI-powered human avatars, receiving personalized feedback on their decisions and their responses in the moment. So this gives them the opportunity to develop confidence and skills needed to handle those challenging situations, and really bringing those gray areas or those nuances to life, and giving people an opportunity to practice and flex those muscles.
Definitely. I'd say that language learning is probably an ideal use case for immersive scenario-based learning. You're letting the learner actually practice listening and speaking and applying vocabulary right there in a simulated context. Maybe it's a simulated the simulated built environment of the end cultural context or country, or the simulated physical natural environment, the ecosystem of that country as well. So fully, immersive simulated context. So we created a Chinese language learning experience for Coursera, where learners can actually visit a Chinese market and they make purchases, they interact with the vendor, they can actually pick up objects. So they pick up the apple and say apple and then have an exchange. You can imagine learners navigating different travel situations. Maybe they're holding conversations with virtual locals. Maybe they're having to react and adapt in the moment, the same way that you would when you're traveling and having need to adapt culturally and use language and context. So VR is providing that contextual and multisensory and experiential learning before, hopefully, the learner gets to actually travel to that country and apply the language learning in the real world.
I absolutely would. VR can be a fantastic tool for employee onboarding. For example, VR allows new hires to step into the shoes of different roles within an organization through immersive day in the life of experiences. So this provides valuable insights and helps them better understand how their role contributes to the bigger picture. So that's really powerful. Additionally, 360-degree video experiences can create virtual office tours, allowing new hires to familiarize themselves with the workplace, which can be particularly helpful for remote or hybrid employees, allowing them to feel connected even when they're not physically there. And VR can also create interactive scenarios that simulate real-world workplace situations, allowing new hires to practice essential skills in a safe and engaging environment. So overall, I would say VR's immersive nature also boosts engagement and knowledge retention, so making the onboarding process just more memorable and impactful. A big part of learning is capturing someone's attention, maybe delighting them, surprising them. That's how you get them to connect with the brand or to remember a message that you're trying to convey. And so VR really allows us to do that by creating more engaging, more effective, more informative, and just more memorable experiences for anyone, but particularly new hires when you're wanting to kick off their journey with a solid and exciting first impression.